All right, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up number 36 is on the screen. And if you notice, I kind of like packed it just with a couple of things that we're going to be working with. But still, number 1, 2, 3, 4 should be a piece of cake. Number 5, I want to see how you develop that one. And we'll go from there. All right, I'll give you guys some time. Copy and go. All right, here we go. Being that it's Monday, I'm going to go over this one more time for some of you that need the extra practice. Start with number 1. One thing that you noticed was that we had fractions all over the place, yes? And by now, you should have been reminded in your noodle that in order for us to get rid of fractions, we need to multiply the entire equation times what? Yes, the common denominator. What would be a common denominator for 2, 3, and 12? Oh, let it go, let it go. This 12 over 1, or 12, yes? So I distribute that here, here, and there. We get 12 over 2x plus 12 times 2 is 24 over 3 equals 12 times 5, that's 60 over 12. From there, we simplify. What is 12 divided by 2? That's 6x. 24 divided by 3 is 8. And 60 divided by 12, that is 5. And now we just solve. Minus 8 minus 8. I end up with, I'm going to continue over here, 6x equals negative 3 divided by 6. So x equals negative 3 over 6, which is what? 1/2. Yes? Kind of, sort of, yeah? And we're like, okay, I see that, all right. Is it coming back? Yes? Because we're about to head in this direction. That's why I'm bringing it back again to give us that extra practice. And that, like I said, that's how it's going to go the entire year. I'm going to introduce certain skills for what's coming up later, give you guys plenty of practice, bring it back again later on, and so on and so forth. Go to number 2, factor. 2 on top, 3 on the bottom. Factors of 2 that add up to 3, 1 and 2, yes? So my factors are x plus 1, x plus 2. Hands if you got that by yourself. All right, good. Next, is it in standard form? Yes. Is there a GCF? Anthony D, is there a GCF? No. But we still have a minus and a square. So let's see if we can take the square root of the first term. What is square root of 4x squared? 2x and 2x. What is square root of 49? Plus 7 and minus 7. That is correct. And those are my factors. So far so good, yes? Yes, Mr. Q, we love these. All right, good. Let's go to number 4. Solve for y. Let's see. So, minus 15x. We end up with 5y equals negative 15x plus 10 divided by 5 both sides. Y equals negative 3x plus 2. And have you got that? All right. My table. Here we go. I got x, y. I'm going to use negative 2, 0, and 1. So, let's do this in our noodle. Negative 2, if I substitute that in here, negative 2 times negative 3, that's positive 6 plus 2, 8. Next, 0. What is 0 times negative 3? 0, that leaves us with 2. And the last one, 1. 1 times negative 3 is negative 3 plus 2, that's negative 1. And let's make our coordinate plane. X, y. So, negative 2, positive 8. Negative 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So somewhere up here. 0, 2, 0, 2, and 1, negative 1, which is right there. Get your line. Don't forget arrows at the end of that line, just to indicate that it keeps going. Yes? And if you got something like that by yourself, okay, you got it. And let's go to number 5. It says, I gave my dog some blocks as toys to play with, and he started stacking them as follows. Figure 1, figure 2, figure 3. Then it says, sketch figure number 6. So, show your neighbor your figure. See what they figured figure number 6 was. Talk it over with your neighbor. What did they get? What did they get? All right. What was our 6th figure? Brandon. Felix. 6 across and 6 down. Hands if you got that. All right. 6 across, 6 down. That means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that should be the 6th figure. So how did you figure that? Talk to your neighbor. We're going to pass it to someone. How can you figure that from that pattern? How did you figure that? All right, pass someone, Brandon. Martin, how'd you figure that? Okay, so walk us through your pattern. 1 and 1. 2 and... So you figured that if figure 3 was 3 and 3, figure 6 is what? Yeah. Hands if you saw that, yes? So far so good. So let's say I continue going and I continue giving blocks to my dog, and I bring a whole truckload of blocks, and he's going to continue going to the nth figure. How would you write that? How would you write that? So how many blocks on this one? 1. How many blocks on this one? 4. How many blocks on this one? 9. How many blocks on this one? 36. And I keep going. How would you write the nth one? Talk to your neighbor. How would you write the nth one? Nth one. Looks like Miroslava's got it. Very good, Miroslava. Good job. Laura's got it. I see her. Very good. Jazzy, I see you, Jazzy. Good, 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 good. Vianney's got it. Let's go. Kimberly looks like she's got it. Very good. Maya A. All right. Well, let's go with Rylan. How would we write it? The nth figure. So this one had 1 block. This one had 4 blocks. And it's the what figure? 2nd. This one has 9 blocks. That was the 3rd figure. This one has 36 blocks, and that was the 6th figure. But we want the nth figure. How do you figure, Rylan? Write n to the n times n. He said n times n. Or in other words, because this is what? To get 36 was what? 6 times 6. This was 3 times 3, 2 times 2, 1 times 1. Or in other words, this would be what? N to the second power. That is correct. Woo-wee. All right, copy the agenda, please. Warm-up number 36, product and quotient of rationals. We're moving on today. And tonight's home play from your books at home that you stashed somewhere in your room that I asked you to clean over the weekend. Go to volume 1. Go to volume 1, pages 438 and 440. Bless you. Only 2 pages tonight, 438 and 440 from that book. You are able to tear out the pages if you need to. That's fine. And reminder, tutoring after school. I'm also here in the morning. So some of you have been taking advantage of that. Come in the morning, asking questions. We go over home play and such. Okay? Once again, warm-up number 36, product and quotients of rationals. And your home play from volume 1. Remember, you have 2 books, yeah? Volume 1, pages 438 and 440. Okay? Copy the code for tonight. If you fall behind on the notes, here it is, LVHIU. LVHIU. All right, so once again, I gave you guys the weekend free of home play. Thank you, Mr. Q. Good. And like I said, do something nice at home. You either wash the car, mow the lawn, clean the house, or a challenge, clean your room. And if all that was done, you made some chilaquiles or something, right, for them? Yeah? All right? All right. Get a Cornell note ready and title it, the objective for today, I can multiply and divide rational expressions. I can multiply and divide rational expressions. Can multiply and divide rational expressions. Do we need a Freire model for rational expressions? No, I see some of you saying no. All right, then tell your neighbor a definition in your own words what rational expressions are. In your own words, what are rational expressions? Rational expressions, what are they? Rational expressions. In your own words, without looking at your notes. What are rational expressions? Anthony E. Rational expressions in your own words. Damn, did everybody hear that one? An expression that is rational. Woo! Bam! Miroslava, in your own words, rational expressions are okay, expressions with what? I heard polynomials, yes? No? Okay, expressions with polynomials in the numerator and denominator, which implies they are what? Fractions. Bah! That's why we don't need a Freire model. We already know what they are, what they look like, what they don't. But we're heading in this direction, okay? I gave you guys a definition. We talked about that. We're going to revisit that today. And writing utensils down, look up to the screen really quick. So today we're going to be looking at multiplication and division of rational expressions. Let me pause the tunes in the back. But I want to take you back to elementary. All right? Here we go. All right, kids. I think you guys were in 2nd or 3rd grade. And your teachers are, we're going to multiply fractions today. 4 15ths times 10 12ths. Okay. So here goes the process. Ready? Straightforward. What is 4 times 10? 40. And what is 15 times 12? 180. Yes? And then from there, Can we simplify? Yes. Divide by 10 top and bottom. Get rid of the zeros. That's 4/18. Can we divide top and bottom by a number? Yes, by 2. So that gives us what? 2/9. Yeah? All right. Well, that's one way of doing it. However, what's another way that we're going to do that today, Mr. Q? Like this. How can we write 4 in factored form? 2 times 2. How about the 15? 3 times 5. How about the 10? 2 times 5. How about the 12? 2 times 2 times 3. Now check this out. I'm going to multiply that times that, which is 2 times 2 times 2 times 5. So far so good, yes? How about these? Well, I'm going to start with 2 times 2 times 3 times 3 times what? 5. And now I can simplify. How, Mr. Q? Oh, the giant ones, yes. What do we have left? 2 and 9. Let's go! But come on, this is too easy, right? How about we just crank it up with polynomials? Let's go! Polynomials. Steps, write the steps down really quick. So this is going to be your blueprint as to what to do for each step. This is the process that we're going to use. Now there's 2 more processes that we can use, but today we're going to use this specific one. And once again, why are we doing it like this? Because that allows me, Mr. Q, to know if some of you, which I doubt, you guys don't do that, but I heard from other teachers that some students go and get their answers from an electronic source instead of them doing their work themselves, which not you guys are my students, but I've heard from other teachers, and that's why I give you a specific process that shows me exactly what we did in class. Okay? So, step 1, we're going to factor completely. Did I show you how to do that with numbers right now? Yes. Then you multiply the numerators, then the denominators, and at the end we simplify by dividing out the giant ones. Straightforward. Okay? You're like, that's it, Mr. Q, that's it. Cake. Actually, we can even have a pop party tomorrow, right? Let's go to get started with our second quarter, right? From the corner. Woo! Look at that wrist. That wrist. Even the left hand. All right. Y'all ready? So I'm going to leave those steps on the side. There they are. Copy example number 1. It says compute the product in quotient, then simplify to lowest terms. Also identify the excluded values. So here's your first rational expression, 3x squared over x squared minus 2x minus 8 times 2x squared minus 6x minus 20 over x squared minus 3x minus 10. All right. I'm going to zoom in. And I think we can do that together, yes? Yes, Mr. Q. All right, so let's get started. Step 1 says to factor everything. So, tell your neighbor how to write 3x squared in factored form. How do we write 3x squared in factored form? Yeah, 3 times x times x. Over. How do we factor this trinomial right here? Negative 8 and negative 2. Think about it. What 2 numbers multiply to give me negative 8 that when you add them or combine them give us negative 2? Tell your neighbor, what are those 2 numbers? What are those 2 numbers? Kimberly, go. 2 and negative 4. So my factors are x plus 2 or x and positive 2, and x minus 4. So far so good, yeah? Yes, Mr. Q. All right. Times. Now we need to factor the next one. Here we go. Look at the numerator. Standard form, yes. Is there a GCF? Yeah, what would be our GCF, guys? 2, and that leaves us with x squared minus 3x minus 10. So I'm going to bring the 2 down here since that's our GCF. So find me the factors of x squared minus 3x minus 10. All right. Looks like Martin's got it. Very good, Martin. But he's going to pass it to David. X plus 2 and x minus 5. So 2 and negative 5. Hands if you got that? That is correct. All right. And who noticed that the denominator is the same as this? Yes? All right. So we write what? X plus 2, x minus 5. All right. Let me zoom out. Let's see where we're at. So step 1, did we factor completely? Yes. Step 2, we're going to multiply. So let me erase this portion right here. So basically, we're going to make one fraction. Here we go. This is how I start. Numbers first, variable second, and then parentheses or binomials third. So let's start with numbers. 3 times what? 3 times 2. Then the variables, x times x. Then the last thing, the binomials, x plus 2, x minus 5. Notice I'm leaving them in factored form, so like that we don't have to do extra work at the end. Next, we did the numerator, this is the denominator. Do we have any numbers by themselves or variables by themselves? No, so let's write it out. X plus 2, x minus 4, x plus 2, x minus 5. Step 2, done. Last step, giant ones. Do we have any giant ones, everyone? Yeah, right here and there. And that leaves me with, what is 3 times 2 times x times x? 6x squared. Next, what is our denominator? X plus 2, x minus 4. Are we doing good? All right. From 1 to 5, how comfortable are you with this? Yeah, 5, 5, 5. We got it. Okay, we got it. Next, y'all ready? Excluded values. Look what I'm going to write. Look up to the screen. X plus 2 equal to 0. X minus 4 equal to 0. However, x minus 5 equal to 0. You're like, what? What am I basing my excluded values on this time? Talk about your neighbor. What am I basing my excluded values on this time? Now, taking you back last week, we got our excluded values from our ending product, right? But in this case, we start looking at the denominator here. What are the two of them? There they are. How about what are the factors for this one? So these are our 4 factors, yes? Do we need to write x plus 2 twice? No, it's already there. And that's how we go with our excluded values. So write that down, please. So this is minus 2, x equals negative 2, plus 4, x equals 4, plus 5, x equals 5. So negative 2, 4, and 5. So once again, those are called excluded values. They also use the term in your book, they say restrictions, meaning what numbers are restricted from being used on that expression. So you can write this restrictions, or excluded values. All right, so I think we got this, yes? All right, let's do another one. See how you do with this one. Copy example 1Q. X squared minus 8x over 14, parentheses, x squared plus 8x plus 15, times the fraction 7x plus 35 over x plus 8. I'm going to give you a head start on this one, see how you do by yourself. Once again, the steps are on the top right. Follow the steps if you get lost, and go. All right, let's see. Step 1, we factor numerator, denominator for both fractions. What? It's frozen? Oh, let it go, let it go. Did I tell you one time I listened to that song like 1,000 times in a day following? I had some twin nieces of mine, and they came over, and one of them had me sit down with her and watch the movie like 3 times or 4. And then here comes the other one, can we watch the movie? I'm all right. So we did. Then later they both wanted to watch it at the same time. I'm like, oh my goodness. All right. Danelli, what'd you get for the numerator factored form? Close. Look up, guys. What is GCF for this one? X, and that leaves us with x minus 8. Remember, go with your process. Start standard form, GCF, and then go with the Power Rangers or difference of squares. Denominator. The 14 could be written as how? 2 times 7, okay. How about factors for the denominator? It's the, Jaylene, what'd you get for x squared plus 8x plus 15? Factors. X plus 3 and x plus 5. Hands, you got that? That is correct. Let's go to the next fraction, numerator. What were your factors for the numerator, Rebecca? GCF is 7 times 5. Hands, have you got that? All right. How about this denominator down here, Anthony D? What is it? Just x plus 8? X plus 8. Let's put that in parentheses. Leave it in parentheses for right now. All right. So far so good, yes? All right, let's go to the next step, which is to multiply them. So numbers first, variables second, and then the factors. So what do I write first, everyone? 7 times x times x minus 8 times x plus 5. Next, 2 times 7 times x plus 3 times x plus 5 times x plus 8. So far so good, yes? All right. Next, let's simplify with our giant 1. You guys see the giant 1s? What are they? What is it? X plus 5. And what? 7 and 7. So that leaves us on the numerator, x minus 8. Denominator, 2, x plus 3, x plus 8. And we are done. Excluded values. Let me get you started. Look up to the screen. I'm going to start with x plus 8 equal to 0. Give me the next ones. Emily, what would be the factors for this one? X plus 3 equal to 0. X plus 5 equal to 0. So far, so good. And then the 14, we can write it as 14 equal to 0, which cancels because it's not true. So, answer. Excluded values. Rylan, go. Negative 3, negative 8, and negative 5. From 1 to 5, I'll come to party with that. 5, 4, 5, 4, okay. All right. I think we got it. Do we need one more, or shall we move on to division? Division? All right. Yeah, I think we got it, right? So, go to division. Look up to the screen. So we covered multiplication. What's so different from multiplication and division, Mr. Q? Well, let me show you. We have to think about our definition that I started with when we started with rational. So look up to the screen. Look up. Let's say I gave you the fractions 4/15 divided by 10 over 12. And I'm taking you back to elementary. What your your teacher say? Show you guys a little process. They're like, keep, change, turn, or whatever the acronym that flip or something like that, right? So I keep the first fraction, change to multiplication, and flip the second fraction. You guys remember that? Yeah, kind of? And then the rest is history because it's multiplication. What is 4 times 12? 48. 15 times 10? 150. Can we divide by 2? Let's see, that's 24. 75. Can we divide by 3? Yes, that's 8. 25. Okay? But once again, are we going to use this same process? Kind of. The first step, I just want to make sure you understand why we do the flip. Not because your elementary teacher taught you that. It's because of the definition. Here we go. Y'all ready? Look up to the screen. 4/15, what does this say? Divided by 10 over 12. Doesn't this look kind of funky? It does, right? But isn't this that? Yes. But according to the definition, look up. M and N, in fraction form, are what? Integers. What are integers? 1, 2, 3, 4, 5, and their opposites. So could there be a fraction in the denominator? No, it has to be a number. What's the easiest number you can think of? Aside from 0, because we can't have 0 in the denominator. 1. How can we make this fraction into a 1? By multiplying it times its reciprocal. What is its reciprocal? 12 over 10. Because what is 12 over 10 times 10 over 12? That is 120 over 120, which is what? 1. And whatever we do to the denominator, we need to do to the numerator. And that's how we do the flip, because of the definition. Now, I'm just bringing this to mind so you understand where it comes from. Do you need to remember it? Not really, as long as you know how to do the process. Now, simple? Yeah? But let's do it with polynomials. How about them apples, yeah? Let's go, Brianna. Here we go. Oh, before we move on, look at these steps. Look at them first. The previous ones that you wrote down were these, yes? The only difference between multiplication and division? They're never the only step different from multiplication and division. Yeah, what are we going to do at the beginning? Multiply times the what? Reciprocal of the second fraction. So, copy this, please. Example number 2. We got x plus 7 squared divided by x squared divided by x squared plus 9x plus 14 over x squared minus x squared plus x minus 2. Copy that. All right, here we go. Y'all ready? Step 1, I'm going to do in red. Let's do this one together. It says multiply the first fraction times the reciprocal of the second. So we're going to multiply x plus 7 squared over x squared times, what is the reciprocal of the second fraction? Well, we just flip it. X squared plus x minus 2 over x squared plus 9x plus 14. All right. Step 1, done. Do we know what to do from there? Yes. So, step 2, it says factor completely. Here we go. X plus 7 squared. How do we write it in factor form? Tell your neighbor, and Andrew's going to enlighten us. X plus 7 squared. How do we write that in factored form? All right, good communication. Andrew, go. Oh, and both. Yes, x plus 7 and x plus 7 twice. Why? Because it says there how many times? Twice. How about the denominator, everyone? X times x. Go to the second one. How do we factor the numerator? Negative 2 and positive 1. What two numbers multiply give me negative 2 that when you add them give us positive 1? Tell your neighbor, what two numbers multiply give us negative 2? When you add them give us positive 1. What are those two numbers? Maya, G. She said 1. Oh, you said negative 1. Negative 1 and 2. Negative 1 and 2? Yes? All right, so it's x minus 1, x plus 2. Denominator, 14, 9. What two numbers multiply give me 14? When you add them, give us 9. Tell your neighbor, when Maya A is going to enlighten us. Two numbers multiply give me 14. When you add them, give us 9. What are those numbers? Maya. 7 times 2. So my factors are x plus 7, x plus 2. All right. So we're done with step 2. Let's go to step 3. Let's multiply or make it into one fraction, yes? So I'm going to start with the denominator. X times x, x plus 7, x plus 2. Numerator, we got x plus 7, x plus 7, x minus 1, and x plus 2. done with step 3. So let's identify our giant ones. Say, neighbor, the giant ones, please. What are the giant ones? Yeah, x plus 7. What else? And x plus 2. So what's left on the numerator? We have x plus 7, x minus 1, and denominator, x times x is x squared. Woo-wee. All right, so before we continue, tell your neighbor the first thing you're going to write for the excluded value, and then we're going to have Martin get us started. What's the first thing we write for the excluded value? Talk to your neighbor. What is the first thing we write? Martin, go. Oh, he went over here? Oh, he's starting with the second denominator, so he wrote x plus 7 equal to 0, and then x plus 2 equal to 0, and then x equals 0, and since it's the same x, we only write it once. Not bad. However, look what I'm going to write. Look up. Where did I get this from? What was the original denominator, guys? This, is that correct? Where did it go after the first step? Right here. And what are the factors here? Does everybody see it? All right, so for division, here we go. Make a note. For division, for excluded values, we use the original denominators, this one and this one, but also the following denominator once we do the flip, which is that one. So we use 3 different denominators, okay? Just make a note for yourself, asterisk heart, and that's your home plate. So once again, make sure you go to your volume 1 of your textbooks and go to pages 438 and 440. You're going to practice multiplication and division. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye. Whew, that was packed.